All right, here's what we're going to be going over today. We're going to be doing the notes for Unit 1, assignment number 7, and assignment number 8. You're probably going to want a ruler, and you're probably going to want 3 or 4 different colored pencils, as I will be using a lot of different colors, so you can you don't have to match up the colors, but you could definitely match up or use different amount of colors that I have. So go ahead and grab those now. Back of the classroom, ruler, 3 or 4 different colored pencils, and you'll be ready to go. Okay, so today in assignment number 7, we're going to be going over angle pair relationships. So what does that mean? Well, it means that we are going to, since there is a pair, this means that we are going to have 2 or more angles involved. So everything that we are going to be talking about today will involve 2 or more angles and the relationship that those angles have with each other. We're going to be going over alternate interior angles, the relationship called alternate interior angles, the relationship called supplementary angles, the relationship known as vertical angles, and the relationship known as the triangle angle sum theorem. Let's start off with alternate interior angles. So to have alternate interior angles, you are always going to have 2 parallel lines. And then you are always going to have a third line that is not parallel with the other 2 parallel lines. Okay, so notice what we have in this picture. For alternate interior angles, we have 2 parallel lines that's one thing we have. That'll be like a bullet point. We have a third non-parallel line. Okay. And the angles that would be considered alternate interior angles, let's say I put an angle down here towards the bottom left of my diagram and I labeled that as angle A. So angle A is this angle right here that I just outlined in blue. And notice that the angle labeled A, it is inside the parallel lines. And then an angle that would be considered alternate with the A would be up here towards the right where I put the angle B that I am outlining in red. Okay, so angle A and angle B would be alternate interior angles. Okay, so notice when angles are alternate interior angles, both angles are inside the parallel lines, and the angles are on alternate sides of the non-parallel line. Non-parallel line. So when you have 2 parallel lines, the lines in purple, and you have a third non-parallel line, the line in green, when you see 2 angles that are inside the parallel lines, in the inside part between the parallel lines, and those 2 angles are on alternate sides of that third non-parallel line, those are called alternate interior angles. So angle A and angle B would be considered alternate interior angles. And when angles are alternate interior angles, the angles are equal. Are equal. Okay, so what does that mean? It means that if I took whatever angle A's measurement is, it is going to be equal to whatever angle B's measurement is. So angle A would be congruent with angle B. You might want a highlighter too, by the way. So go get a highlighter if you don't have one. Okay, that is the biggest thing that I want you to remember. Alternate interior angles, the angles are equal. So angle A's measurement in degrees would be equal with angle B's measurement in degrees. Okay? All right, let's move on to supplementary angles. So the word supplementary in a math class, that is a word that we use that stands for adds together to make 180 degrees. 180 degrees. Okay, so whenever you see the word supplementary, that means that the angles, supplementary angles, that means the angles are going to add together to make 180 degrees. Okay. Here is a very common picture of angles, two angles, a pair of angles that add together to make 180 degrees. Very common example. Okay. So you can see that I just created two angles in this picture. I'm going to label them as A and as B. So the A angle is right there. It's that acute smaller angle on the left that is, I am outlining in blue. And then the angle right next to it, side by side. So notice, which is I'm denoting as B and it's red, and the B angle is that one right there. Notice that the A and the B angle, they share a side of their angle right here. This side is both the angle, it's a side for angle A and angle B. But notice that the A angle and the B angle, they are side by side next to each other. Okay? So whenever this happens, side by side next to each other. Side by side angles. That means that those angles are going to add together to make 180 degrees. In other words, when angles are side by side angles, they will be supplementary angles, okay? So what does that mean? It means that if however the angle A, however many degrees angle A is, when I add it with however many degrees angle B is, the two angles together are going to add up to equal 180 degrees. Okay? Side by side angles, that means that the two angles together add up to equal 180 degrees. That's going to be very important. So whenever you see side by side angles, the two angles add up to be 180 degrees. Okay? All right, moving on to vertical angles. So whenever we have vertical angles, what you're going to see is you're going to see an X. So vertical angles, you will always see an X. And by an X, I don't necessarily mean the letter X. What I mean is that you are going to see a diagram where you have two lines that intersect each other, and they make the X pattern. So for vertical angles, you want to think of the X pattern. The X pattern. you will always see a pattern that forms the letter X, such as this. Now, an example of a pair of angles that would be vertical angles would be, let's say I have this angle on the left that I label as A, and that is that angle that I just outlined in blue. And then the angle right across from A that I just labeled as B, that is in red, that I'm outlining in red. Notice that those two angles are across from each other, okay? So those two angles would be considered vertical angles, all right? So vertical angles, and then there's a couple things that I want you to remember about vertical angles. Vertical angles are equal to each other. So whenever you get a situation where you go, oh, I've got that X pattern, and you've got two angles that are across from each other, like angle A and angle B in this diagram, those angles are what are called vertical angles. And then that means then that those two angles are going to be equal to each other. So that means in this diagram, whatever degrees angle A is, that is going to be equal with whatever angle B is. So angle A is going to be the same as angle B, okay? Very important. Vertical angles are equal to each other. So that means the two angles, angle A and angle B, will be equal to each other. Okay, let's go to the last angle relationship that we're going to talk about today, the triangle angle sum theorem. So the triangle angle sum theorem says that all three interior angles of any triangle add to equal 180 degrees. Okay? So the triangle angle sum theorem says that if I take any triangle, it does not matter what type of triangle it is, big, small, a right triangle, an isosceles triangle, whatever, and if you take angle A, which is an interior angle, and the reason why it's an interior angle is because it's on the inside. It's one of the inside angles of the triangle. And if you take however many degrees angle A is, and if you add it with another interior angle, which I will denote as B. Notice angle B is another angle inside the triangle. Add that with angle B. And then if you add those two angles to the third angle inside the triangle, which I will denote as angle C, the triangle angle sum theorem says that those three angles, as long as they're inside the three angles, inside the triangle, they're called interior angles, they will always add up to 180 degrees. And that'll be the case for any triangle. It doesn't matter, because this is the case for all triangles. So the triangle angle sum theorem. All three, the three interior angles added up together, always equal 180 degrees. Okay? So there's our basic general rules about angle relationships, alternate interior angles, supplementary angles, vertical angles, and the triangle angle sum theorem. Remember, in these right here, two of them are equal to each other. When we talk about the angle pair relationships, the alternate interior angles and the vertical angles are equal to each other. And then the supplementary angles, when you have side-by-side angles, and when you have the three angles inside a triangle, those angle relationships, they add together to equal 180 degrees. Okay? So we're going to get back to the area model with products and sums in our notes in a second. But go ahead and turn the page to your notes for assignment number 8. And what we're going to do is we are going to do an example of where we're going to use alternate interior angles. And specifically what we're going to do for these alternate interior angles is we are going to, one, we're going to write an equation using the given diagram, and I'm going to give you a diagram in a second. And 2, we're going to use the equation to solve for the value of x. Okay, so that's what we're going to do here. We're going to write an equation using the given diagram, and we're going to use the equation to solve for the value of x. Okay, and here's what the diagram looks like. I have a purple line. I have a second purple line. And these purple lines are parallel with each other as denoted by the arrows. I have a third line that is not parallel with the purple lines. And then I have an angle inside this diagram denoted by the expression 7x minus 2 degrees. So where that 7x minus 2 is, that's saying that blue angle right there is the expression 7x minus 2 degrees. Okay, this is an algebra equation or type of problem. And then the angle down here where I'm writing the 5x plus 34 degrees, that angle is denoted by what I am outlining in red. Okay, so what you have to do is you have to go, okay, I have two angles. I have to write an equation using the given diagram. You have to decide what's the relationship with these two angles. Okay, and if you notice, both of the angles, the blue one and the red one, they're both inside the parallel lines. And not only are they inside the parallel lines, but the blue angle and the red angle are on alternate sides of the non-parallel line. So this means that these two angles right here are alternate interior angles. Okay, so what we are dealing with in this problem is we are dealing with alternate interior angles. Now, what does that mean? Why is that important? Okay, here's why. Alternate interior angles are equal to each other. We got that from the notes. They're equal to each other. So what does that mean? Because they are equal to each other, it means that the equation that can be written is the equation. You take the representation of the blue angle, 7x minus 2 degrees, and it means that it is equal to the representation of the red angle, which is represented with 5x plus 34 degrees. Okay, so when the problem that we have says, step 1, write an equation using the given diagram, 7x minus 2 equals 5x plus 34, that is the equation that I get from this diagram. And I was able to write that equation because those two angles, the 7x minus 2 and the 5x plus 34, those are alternate interior angles, and alternate interior angles are equal to each other. So that's why I was able to take the two parts of the equation and make them equal to each other. Okay, now that is part one of my problem. Write an equation using the given diagram. Part two of the equation is use the equation to solve for the value of x. So now we're going to use this equation and we are going to solve for the value of x. And there's a couple different ways that I can do to solve this. Here's how I'm going to solve it. First thing I'm going to do is I'm going to take these 5x's and I'm going to minus 5x's from both sides of the equation. What that's going to allow me to do is I'm going to bring down the equal sign, and it's going to put all the x's on just one side of the equal sign. Notice 7x minus 5x is 2x. I bring down the minus 2. Over here on the right side of the equation, the minus 5x cancels out the 5x. And then I just bring down the 34. So now I have the equation 2x minus 2 is equal to 34. And I continue to solve. So my next step in this equation is I would add 2 to both sides of the equation. Now, when I do that, I bring down the 2x. That plus 2 would cancel out the minus 2. I bring down the equal sign, and 34 plus 2 is 36. And then my last step would be to divide 36 by 2. So I get x is equal to 18. Okay, so that right there is my answer. X is equal to 18. All right, now notice what I did was I took the equation that I had written, and then I just used the equation to solve for x. And I got x to be equal to 18. Okay, so there's an example of how I take the fact that I have alternate interior angles in a diagram. I know that alternate interior angles are equal to each other, so that allows me to write an equation. And that equation then allows me to solve the equation for x. Okay? All right, so we are going to skip the proof of alternate interior angles are congruent part in our notes on assignment number 8. But we're going to go back up. I'm going to go back up. You're going to go back to your notes for assignment number 7. And let's review what we mean by area model with products and sums. Okay? So here's what I mean by area model with products and sums. So an area model is going to be in the shape of a rectangle. So go ahead and draw a rectangle in your notes here. Divide this rectangle in half vertically, like I just did. I've drawn a vertical line that cuts it in half. And then also divide the rectangle in half horizontally. So in other words, we create 4 individual rectangles. Okay? At the top of the outside of the top left rectangle, write a 3x. On the outside at the top of the top right rectangle, write a plus 6. On the outside on the left of the top left rectangle, put an x. And then on the outside of the bottom left rectangle, on the outside on the left, go ahead and put a minus 3. And remember now what we're going to do is we are going to find the area of each one of the individual 4 rectangles by always going the length times the width. And then we are going to combine each one of the areas together. Okay, so let's go ahead and find the area of each individual rectangle one by one, starting with the top left rectangle. So I'm going to multiply the length, 3x, with its width, which is x. And recall that 3x multiplied with x is 3x to the second power, or 3x squared. So the area of the top left rectangle is 3x squared. Moving to the top right rectangle, I'm going to take its length, which is positive 6. I'm going to multiply it with the width, which corresponds with x. 6 multiplied with x gives me an area of 6x. So the area of the top right rectangle is 6x. Moving to the bottom right rectangle, I'm going to take the length of the bottom right rectangle, which is positive 6. I'm going to multiply that with the width, which is negative 3. 6 multiplied with negative 3 is negative 18. So the area of the bottom right rectangle is negative 18. Moving over to the bottom left rectangle, I'm going to take the length of the bottom left rectangle, which is 3x. I'm going to multiply that with the width, which is negative 3. 3x multiplied with negative 3 is negative 9x. So that means that my total area would be all 4 rectangles' areas added up. So in other words, the 3x squared added with the 6x added with the negative 9x added with the negative 18. And that would be your total area if there was nothing that you could combine to like terms. But as you can see, the positive 6x is a like term with the negative 9x. So I can combine these two together. And that would give me, bring down the 3x squared. So positive 6x plus negative 9x gives me negative 3x. So I just put a minus 3x. And then I bring down the minus 18. I don't have to bring down the plus. I just bring down the minus 18. So my total area is 3x squared minus 3x minus 18. Okay, and that, if you recall, that 3x squared minus 3x minus 18, that is what we refer to as the area, the sum. This part right here is what we refer to as the sum of the area. Okay, then that is equal to what we refer to as the product of the area. Okay, and if you recall, to write the product of the area, we start a parentheses and we write what's along the outside top of my area model, 3x plus 6. And then I close the parentheses. And then next to that 3x plus 6, I start another parentheses side by side with it. And then I write what's along the outside left of my area model, x minus 3. And then I close the parentheses. So the product of the area is the 3x plus 6 being multiplied with the x minus 3. Those are the outside parts of my area model. I represent them with side-by-side parentheses, and that is equal to what we refer to as the sum, which is 3x squared minus 3x minus 18. Okay, guys, there's some good solid notes for the 7 and 8.